EPR approach for better waste management system for mobile phone design in Indonesia. According to World Health Organization, e-waste connected health risks may result from direct contact with harmful materials such as lead, cadmium, chromium, brominated flame retardants or polychlorinated biphenyls PCBs, from inhalation of toxic fumes, as well as from accumulation of chemicals in soil, water and food. And the increasing numbers of e-waste is growing significantly every year.
The problem of electronic waste or e-waste can hazardous to human health and environment. This is due to the effect of dangerous toxic substances such as lead, mercury, chromium, cadmium, PBDE, and other heavy material if they are not managed properly. Open dumping and crude waste handling in landfill sites in Indonesia create an even more miserable situation. Damanhuri, 2010. Mobile phone or cell phone is considered as one of the fastest growing device in global society. More than 60% of global population have mobile phone, and even an individual may have more than one device. Heavy consumerism and tight competition among manufacturers also lead fast consumption by releasing new models each year. In Indonesia, the increasing numbers of electronic waste of mobile phones should be taken into account by the manufacturing industry, producers, brand distributors and governments to draw attention to deliver better waste management system, and it is related to extended producer's responsibility, EPR, and waste of electrical and electronic equipment or WEEE, Borner and Hager, 2018.
This method is adapted from previous research by BRNER and Hager 2018 and Thorpe et al. 2004 that build theoretical framework by taking e-waste governance, government regulation, and EPR strategy. Firstly, it will investigate WEEE-related problems with Indonesian government regulations and EPR-related issues by examining the literature of previous studies. Secondly, it would observe waste management problems of mobile phone concerning EPR cycle in society. By investigating the observed situation of an authorized mobile phone service center, to find some insights for proposed concept. Mobile phone components will be examined from the aspect of ease of dismantle through simple simulations with standard equipment. This is to see how difficult the component is disassembled and how it will affect on the EPR cycle. Thirdly, alternative design solutions of how EPR approach might be implemented in the design development of new products.
EPR or Extended Producer Responsibility or also called Producer Take-Back, Thorpe, et al. 2004, is the policies that should involve closed-loop scenario in material management and should be thereof managed and processed by reusing or recycling the materials into new product or other packaging products with less energy consideration rather than producing new product from new material. This approach replaces traditional linear thinking and is based on the concept of supply chains manufacturing system. Retailers and the consumer all share an end-of-life product management. In addition, recycling programs as part of the EPR, like existing now, cannot handle all of the hazardous waste from electronic goods.
End-of-life phase. Huang et al. 2019 implied that there is strong correlation between durability and recyclability choices. They further explained that the more rigid recycling targets, it would lead to the increased recyclability and durability. So in terms of EPR, producers might need to find better recycling method to find valuable recycling materials in order to create more durable products as well as recyclability. Huang et al. 2019 also stated that easier recycle of product design will increase recycling value at the end of life phase and durable product design will reduce the total volume has to recycle and will lead to cost reduction as well. The example of design implementation in end-of-life phase is conducted by Apple, Inc. Since 2017, Apple has been trying to use recycled and renewable raw materials. The raw material is designed so as not to produce too much waste and to have a long service life. When the product reaches the end-of-life phase, Apple ensures that the product returns back to the company using the trade-in system, and the material will be recycled to become a new product. The strategy used is to create a circular supply chain with strategies as follow: designing and building products and packaging make a durable product.
The observations were undertaken in an electronic mall to observe the current practices of non-organized mobile phone service in handling the e-waste. Parts, components that can still be used were mostly used for personal testing. There is no special waste disposal site for electronic waste around, and there is no system, regulation that requires the safe sorting and disposal of electronic waste. Phone distributors do not care about broken cell phones or spare parts waste in the individual service center area.
The analysis shows that current e-waste handling of mobile phone in Indonesia has not yet implemented the EPR, even though there are government regulation that might govern to these issues. For example, there is regulation regarding material extraction that should be handled properly by authorized party, but in reality, there were many neglected actions such as open dumping and dangerous process. Table 3 shows 3 different types mobile phones that were dismantled to simulate how difficult the dismantling process is undertaken by a legal party or personal user. 4 major components were dismantled by using ordinary tools such as screwdriver, pliers, heat gun, etc. Each component is given score range 5, the most difficult, to 1, the easiest. It is shown that iPhone has lower average score 2.75, that is easy to dismantle, and Asus has highest score 4.75. It is indicated that in overall, the separation process is considered as medium to high ease of separation. For unibody type of phone employs adhesive and make it harder to get dismantled. There are still plenty of mobile phone designs which do not provide ease of dismantling. The solution is proposed to create mobile phone design concept that is easily recycled using the extended producer responsibility system approach. This will involve users in mobile waste management and treatment systems in a closed loop cycle. In terms of EPR, this study would like to propose end-of-life phase design concept that is focusing on easy recycle product design. Huang et al. 2019, which covering several issues: collecting process, pre-treatment separation, material recovering method, and safe disposal concept. This end-of-phase concept is taken into account as a bottom-up approach to see a deeper problem of Indonesia's situation related to EPR life cycle. The design concept implementation into practice might rethinking that each mobile phone components are easy to dismantle and replace when it's broken and could be marked so can be separated directly by the mobile phone service parties authorized or unauthorized. This will include the service and system design that will relate to EPR application so that can comply with government regulation, i.e. Law No. 18/2008. The study shows that EPR has not yet well implemented in Indonesia, especially in handling mobile phone waste issues. Unauthorized service and illegal party are still neglecting the safe treatment due to lack of awareness and technology. Hence, it is important by considering Indonesian situation, the producers need to employ new design strategy not merely in order to meet regulation compliances. It should extend the responsibility for better waste management friendly product design that is more suitable with Indonesia's situation with minimum waste management infrastructure by involving end-of-life design solution, better collection, separation, recyclability, reuse and ease of manufacture. Further research might be needed to find the correlation between design variables and EPR values through statistical analysis.